Today's lesson is on the fundamental theorem of algebra. So what this says is that if you have a polynomial of degree n, then the polynomial has n zeros in the complex number system. Okay, so that means if I have a polynomial of degree 5, okay, so there's a polynomial degree 5, then that means that there are 5 zeros, and it's a combination of real and imaginary numbers. So we've talked about how there could be a maximum of 5 x-intercepts, 1, 2, 3, 4, 5, but there might be less than 5. So maybe there's only 1, 2, 3. So maybe there's 3 real solutions, and then that means there would be 2 imaginary solutions. Okay, and now the conjugate root theorem says that if a polynomial has a root of a plus bi, so there's that kind of complex imaginary number, then its complex conjugate a minus bi is also a root. Okay, so what that is saying is that if you have imaginary solutions, that they come in pairs. And they come in pairs because of that there's always that plus minus. So maybe like a plus or minus bi. So either you would have maybe you have 0 imaginary solutions, but if you have some imaginary solutions, they're going to come in pairs. So maybe you have 2 of them or 4 of them or 6 of them, but never an odd number of imaginary roots. Okay, so here we have a polynomial x to the third minus 8, and we're setting it equal to 0 because we will be solving for x values. But first, thinking about the theorems, we're going to talk about what is the possibility for how many real solutions and how many imaginary solutions. So remember that imaginary solutions come in pairs. So if we have 0 imaginary, then that means we would have 3 real. We can't have 1 imaginary, but we could have 2. So if we have 2 imaginary, then that means that there's 1 real. And those are all the possibilities of answers. So now let's try to find them. If you remember, this is the difference of 2 cubes. So we are going to factor that. This factors to x minus 2 times x squared plus 2x plus 4 equals 0. And then we're going to solve by factoring. So x minus 2 equals 0, and x squared plus 2x plus 4 is equal to 0. So this one's easy, x equals 2. So there is a real solution. Okay, this one here, it is not factorable. So I have a quadratic that's not factorable. How else can I solve quadratics? I'm going to do the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's simplify that. Negative 2 plus or minus the square root of 4 minus 16 is negative 12 over 2. So negative 2 plus or minus the square root of negative 1 times 4 times 3 So negative 2 plus or minus 2I square root of 3 over 2. Now, because we have all these 2's, I can divide this and this both by 2. So I'm going to go up here. So this would be negative 1 plus or minus I square root of 3. So that would be 2 imaginary solutions. So 2 plus 1 is my 3. Okay, let's do another example. X to the 4th plus 4x squared minus 12 equals 0. Okay, so first, if the degree is 4, I have to look at the possibilities for combinations of real and imaginary. So it's possible that if I have 0 imaginary solutions, then I will have 4 real. These come in pairs, so if I have 2 imaginary, I'll have 2 real. Or I could have 4 imaginary and then 0 real. Okay, so now let's look at this. This is one of those special case 4th degree polynomials where we can factor it into the x squared factors of negative 12 that add up to 4 would be plus 6 and minus 2. So I'm going to set both of these equal to 0. X squared plus 6 equals 0. X squared minus 2 equals 0. Solve both of them. So x squared equals negative 6. So x equals plus or minus the square root of negative 6. Well, there's 2 imaginary solutions. X equals plus or minus I square root of 6. And then over here, x squared equals 2. X equals plus or minus the square root of 2. So this is your 2 real solutions. They're irrational, but they're still real. And then these are our imaginary solutions. All right, last example, x to the 5th minus 5x to the 4th plus 5x to the 3rd minus 25x squared plus 6x minus 30 equals 0. Okay, so if I have a 5th degree polynomial, okay, possible imaginary. So if there's 0 imaginary, then there's 5 real. 2 imaginary, then there would be 3 real. You could have 4 imaginary, and then you could have 1 real, and that's the combinations for your solutions. Okay, this is a higher degree polynomial. So factoring, let's think about all the possible rational zeros. So factors of 30, plus or minus 1, plus or minus 2, 3, 5, 6, 10, 15, and 30. So this is when we could get out our calculators, plug this in, start looking for some zeros. I'll help you out. The first 0 that I found was 5. So let's do synthetic division with the 5. 1, negative 5, 5, negative 25, 6, and negative 30. Okay, 1, 5, 0, 0, 5, 25, 0, 0, 6, 30, 0. So that means I have the factor x minus 5. And then this will be x to the 4th plus 5x plus 6. This is all set equal to 0. And then you should recognize this is one of those special case 4th degree polynomials. So we can factor. So x minus 5, and then x squared times x squared. Okay, factors of 6, that could be plus 2 plus 3, which would add up to 5. Okay, let's set all of these equal to 0. So x equals 5, there's a real solution. X squared equals negative 2, so x equals the plus or minus I square root of 2. There's 2 imaginary solutions. X squared equals negative 3. So x equals plus or minus I square root of 3. So this one has 4 imaginary solutions and 1 real solution. So there is your full lesson on the fundamental theorem of algebra. Good luck.